Hi, in this lesson, we're going to look at how functions can be used inside our programs to make them more efficient and easier to read. Using functions in Python graphics is exactly the same as using them in our console programs. To define a function, we use the keyword def and write the function name and any parameters followed by a colon. Indented inside, we list all of the actions we want that function to complete and can use the parameter names to control different commands in our function, such as the color variable being used to control the color of the circle we're drawing here. To call our function, we simply write the function name and enter needed parameters inside parentheses. We can call our functions as many times as we'd like to add multiple shapes to our canvas. Let's take a look at an example to see this in action. We're going to complete this exercise where we're being asked to draw trees to the screen using a function. The location of each tree should be given to the function as a parameter, and the dimensions of the tree should follow the constants laid out. Before we dive in, let's think through how the height parameter and the y location of the tops of the trees are related. Let's say these were the height values given to the function, and the total height of the canvas was 400 pixels. The y coordinates on the canvas start from 0 at the very top and increase as we move down, until we reach the total height of our canvas, or 400 in this case. This means that the y location of each point is going to be found by taking the canvas height value of 400 and subtracting the height of the tree given from the function. Okay, now let's plan out how to solve this problem. We're going to start by determining the dimensions and location of the tree trunks. We'll look at the middle tree as our example. Finding the width of the trunk is easy because it is already given to us as a variable. Now the height of the tree is dependent on the height value given to the function, so we'll have to do some math here. We can start with the height given to the function and subtract the leaves height to get the height of the tree trunk. To find the x-coordinate of the trunk, we'll need to start with the x-coordinate given to the function and subtract the tiny bit that is half of the width of the trunk. To find the y location of the trunk, we can start with the total height of the canvas, subtract the height given to the function, and add back the leaves height. Now let's determine the dimensions and location of the tree leaf sections. We'll look at the middle tree as our example. Finding the width and height is easy because they are already given to us as variables. We find the x location the same way we did for the tree trunk, but this time we'll subtract half of the leaves width variable from the x location given by the function. And to find the y location of the leaves, we just have to subtract the height value given from the function from the canvas height. Now let's head to our editor. When we first start this program, we see that the width and height of the canvas are being saved into variables canvas width and canvas height, and they're being used to size the different parts of our shapes. So we want to create a function that will draw a tree for us. And we want this function to take an x-coordinate of where the tree will be located, as well as the height of the tree. Let's start by just drawing the trunk of the tree. So we'll save that in a variable trunk and use our rectangle keyword, where the width of our rectangle is going to be trunk width. And the height, which we calculated previously, is the height given by the function and subtract off the leaves height variable. Now let's set the position of the trunk, and we'll use the positions that we found when we were planning our program. So we'll start with the x location given to the function, subtract off the leaves width divided by 2 for our x, and for our y, we're going to use the entire height of the canvas, subtract off the height given by the function, and then add back the leaves height. Let's set the color of our trunk using a hex code, and that code is going to be 3F301D. And we can add our trunk. Now, we could continue filling out this function and add the leaves, but we might want to test our function now, just adding the trunk to make sure that it works before we move on and add more parts of our program. So we can call this function, and let's just put in some values for x and our height of our tree. And we see our trunk, we don't have any leaves, but our trunk is working correctly. So now we know we can continue on creating our function, and we know that the first part is going to be correct. So now let's add the leaves. And the leaves are a rectangle as well. And those are just going to be leaves width and leaves height, easy dimensions. We're going to set the position of our leaves, and that x is going to be x minus leaves width divided by 2. The y is the full height of the canvas minus the height value given to the function. And we'll just set the color of these leaves to color.green and add the leaves. Now, we already have one function call, so let's see how this works. Our leaves are not perfectly centered, and we can see that when we were setting our trunk, we actually used leaves width divided by 2, and we should have used trunk width divided by 2. Let's see if that fixes our problem. Great. So let's try to add more trees. We can draw a tree using 50 as the x coordinate and 200 as the y. And let's also draw another tree at 250 with a height of 400, a tall tree. Perfect. We see 3 different trees at 3 x locations and 3 different heights.